Hello everybody, my name is DougEngdahl. I'm with the Axiom Exploration Group. Just want to thank the BC government and the Smithers Exploration Group for inviting me here today to talk at Rock Talk's first virtual conference. I'm going to be talking about the modern exploration toolbox and the applied integration for a more efficient exploration program. The Axiom Exploration Group is a consulting and service-based company that works across many industries, from forestry to agriculture, infrastructure inspection, environmental reclamation and remediation, and mining and mineral exploration. Having insight into all these industries and the technologies used in them has allowed us to cross-purpose these technologies into different industries and stack those technologies to be more efficient. We're going to talk about the British Columbia's Golden Triangle today, where most of the audience probably has some interest in. It's an extreme terrain where the season is short and the terrestrial work is difficult. Modern mineral exploration continues to increase in complexity and cost. As geoscientists, our exploration approach and techniques are required to evolve in parallel with technological advancements, minimize expense, and maximize probability of significant discoveries. Some of these techniques today allow us to accomplish this are utilization of satellite data, co-collection of geophysical and geomatics data, and advanced machine learning targeting software for multivariable simulation modeling, resulting in extreme value-add interpretations. One version of this economical approach is best described as a multi-phase macro to micro method, which uses the efficient acquisition of multiple integrated data sets with a continually decreasing area of interest, directly correlated with increasing the data resolution and advancing the processing that results in greater accuracy of interpretation. By combining remote sensing techniques using synthetic aperture radar data and multispectral imaging to analyze structural trends, vegetation, alteration signatures, and ground movement patterns, we can identify complex anomalies, integrating features both at surface and at depth over large areas quickly, effectively, and economically without seasonal restrictions. This then creates a more defined area of interest for targeted terrestrial exploration and aerial geophysical data acquisition. With recent advancements, we can now co-collect multiple airborne geophysical and geomatic data sets simultaneously. And then geophysical work can again be completed at an even more focused level with high-definition UAV or ground geophysical surveys to define detailed subsurface drill targets with the goal of intersecting the longest intercepts and the highest grades. With a continually growing database of both publicly available and acquired geological, geochemical, and geophysical data sets combined with multiple focused satellite analysis, we are able to run countless simulations of known successful analogs globally to increase discovery probability. This critical strategy of mitigating the acquisition of costly, high-resolution data over areas of minimal potential is for the benefit of maximizing exploration budgets, allowing for advanced machine learning results and the discovery of significant resource numbers. I want to thank Handstone Gold Corp, Raymond Marks, and Ominica Mining and Metals, Tom McNeil, for allowing us to use some of their data today in our presentation. Handstone Gold Corp is active northwest of Stewart in the Golden Triangle, and we're going to look at some properties up here with the use of satellite data acquisition to refine the area of interest for more detailed geophysical acquisition. This claim boundary here is about 42 square kilometers, and if you were to plan a geophysical survey at 100-meter line spacings, you'd be looking at 456 line kilometers. Through the use of publicly available satellite data and in-house derived algorithms, we're able to create such products like regional elevation and displacement, local displacement, iron and carbonates, quartz abundance, aster argillic alteration, hydrothermal alteration, propylitic alteration of epidote and chloride, lithium-bearing hydrothermal alteration, ferric oxides, ferrosilicates, metal stress vegetation, and iron oxides. Now, not all are applicable to every area. And we're going to look at just 3 of them today for a more refined area of interest. Propylitic alteration, ferric oxides, and ferrosilicates. Looking at that area north of Stewart, BC, you can see the propylitic alteration with the warm colors being higher intensity and the colder colors being less. You can see an extreme amount of area where there is no alteration apparent. Looking at ferric oxides, it's a similar area of interest. Again, the darker being the higher concentration of ferric oxides. And the ferrosilicates, again, showing the same signatures and area of interest. You can even see the stream showing the same signature here through erosional and runoff. So if you took that 42 square kilometers of this entire area and reduced it to these satellite defined areas of interest, you're now looking at 17.2 square kilometers at 100 meter space flight lines of 188 line kilometers. Drastic difference in flying a geophysical survey over your entire claim block. So comparison side by side, 42 square kilometers of the entire area, 17.2 with the defined focused areas of interest. In looking at the southwestern corner of that property, we ended up flying a UAV mag survey over the highest concentration of alteration. This survey was very detailed, at 25 meter line spacings, and created some great drill targets, of which produced some great gold intercepts. Now the satellite analysis works really great for areas of a lot of exposed rock or outcrop, but that's not always the case. So looking at Amanika Mining and Metals, their properties near Quesnel, BC, just west of Barkerville Gold, or now a Cisco's operation, where outcrop is not very abundant and you have a lot of vegetation covering your entire claim block. So satellite analysis through metal stressed vegetation and a few other alteration products have some application, but they're not as efficient as they would be in areas like the Golden Triangle where rock exposure is abundant. So here we took a look at using regional mag data to redefine your area of interest inside your claim. Taking a look at a regional mag set here, in this total claim block encompassing 563 square kilometers, or 4,900 line kilometers at 100 meter line spacing. It's a very expensive geophysical survey, no matter what it is, EM, mag. Using the regional mag data, we ended up redefining the area of interest inside the claim block, reducing it to 207 kilometers square, or 2,276 line kilometers at 100 meter line spacing. And we flew a triaxial gradient mag over this area here, shown with a greater level of detail. Taking it one step further, we then flew a UAV mag survey at 25 meter line spacings for a very high level of detail, as you see in front of you. Now the use of regional low resolution data to redefine your area of interest is not new to any of us. I'm showing you the increasing level of detail and data, which comes with an increasing cost per area, to highlight what is required in order to feed customized machine learning software to effectively search for defined features of interest. When using ML to identify angular relationships in geophysical data, the higher the resolution equates to the greater level of confidence in the results. This also applies to LiDAR data. When looking for features of interest like resistive quartz veining or other structural features, a very high point density is required to pull out any usable geological data for targeting purposes. So after looking at two methods of a macro to micro exploration approach with both satellite and regional data to maximize exploration budgets, last year we decided to take it one step further and started co-collecting triaxial gradient mag and high resolution LiDAR data, thus drastically reducing the acquisition cost while increasing the data density. Now, looking at the image on the bottom left, this is an image from the Golden Triangle. This is a DEM created from 100 plus points per square meter. This level of data density allows our ML to identify important structural features used for focused terrestrial exploration. We have also successfully developed an alternative to ground EM with the use of drones, which we will release to the industry in Q2 of this year. In short, what I'm trying to say is, as scientists, we should never settle or stop advancing technology to further our industry. Thanks for your time, and this was brief. I could talk for hours on this, but I think there's a Q&A to follow, and I'd be happy to answer any questions on that platform or by email in the future. Thanks for your time.